you for inviting me. And yeah, I come from Boston, and I work in a cognitive visualization lab. And well, is this between data visualization and machine learning? Essentially, is a unit inside to the Watson group, no, is a team that try to provide machine learning for everybody, essentially. And probably you remember Jeopardy game. Let's see, today we'll talk about some of my project and some of the projects that we build with my team in a Watson group. And so this is the menu of the day. There are not so many content, but we will go deeply inside to different projects. So just a quick introduction. This is the lab in Astor Place. So my team is not so big, like you can see, but sometimes I'm a project leader of a much bigger team to build some specific delivery. And sometimes I'm working with the design team inside to this idea to create the right type of GSS, the right type of representation of information, interaction, the type of persona that really match with the customer that would be part of the stakeholder of Watson group. Sorry for this up and down. My computer is here, and I forget my remote control. My experience starts with this idea of cognitive. So, of course, cognitive, you think about the brain. And the brain, so it was my first year in a group, and I decided to find this nice name, Cognitive Visualization Lab, without knowing very deeply why cognitive. Essentially, everybody was talking about cognitive. And I decided to start this project with different two interns 2 years ago inside to Harvard University in collaboration with some laboratory in MIT to build an interactive tool to discover what we know about our brain. So no, I come from a completely another field, and I think this is a very good way, if you are an expert in interface, in data visualization, to enter in different fields, start to plot information from in this case, information that comes from an experiment. Essentially, in front of this person, there are different stimulation, and every time there is a stimulation, there are a different area of the brain that start to work more, absorb more oxygen. And the idea is to provide a tool, an interactive tool, to see in what way these areas interconnect. So what really surprised me, and the experiments are very primordial, like I look at a color, a woman, a man. So, and I smell something good, something bad. And the area of the brain that are activated are different for different people. And what we really know is this macro area is working more in collaboration with this other macro area. So we can build a tool to really identify this network of the area of the brain that work together to, after some stimulation, like looking red, and that's it. It's what we know about our brain. And this, of course, if you are from the field, you can think that my surprise is very naive, but I was thinking that maybe the technology was a little bit more, we don't know too much. Essentially, it's no way to use information from our brain at the moment to really build the right data visualization. So we cannot really use this scientific information from the brain now to really evolve a very sophisticated theory about in what way provide complex data visualization. So essentially, cognitive have another meaning, and let's see together what is the meaning. The definition of artificial intelligence can be, for some of you, very scary. This is one IBM exposition many years ago, and there is this scary robot that talks with you, but still there is something that is very close with our idea of cognitive that I'm close to introduce. Essentially, there is something that is no human that talk with you. This is a little bit more evolved. There is storytelling that comes from this machine. That this movie is a little bit more sophisticated. But a huge amount of information become a storytelling, become maybe just voice. And Of course, we are so far away from this level. And we are close to this level of knowledge about what we can do with a computer. And now, this is a chess, but now you know we can win and go too. It's much more sophisticated for a number of... this no effect I introduced. This green matrix effect is not from my slide, but I think it's very beautiful. And okay, Kasparov is a little bit upset about what we can do now with this machine. But I think everybody are a little bit surprised about what happened in 2011. So I think the funny of the sad part depends from the point of view. And when the machine is able to work in a field, in this case, resolve the question from this type of game, it's not just a win, it's humiliated the competitor, the best competitor. Of course, you have to think that it's not so easy to move from this stage of winning in this type of field where every single question have a very strong meaning and there are very few possibilities. So there is a way to really to identify the answer. But in our daily life, we use our language in a more flexible way. So a word means different things in different fields, and the way that we talk frequently don't have really any logical meaning for real, not just for the machine, but if you really analyze your consecutio temporum, sometimes we talk in a way that don't really have a sense. This happens very frequently. So what is a cognitive system? What is the boundaries of what we can do today to really activate this type of dialogue between us and some artificial intelligence entity? I think the definition that we use in Watson is this ability to interact naturally with people. And of course, what it really means is, first, you need to understand who are the people, and it is very complicated. And now we will see a little bit of what we know at the moment about the people. And after, the interaction had to be appropriate in function to the people and the context. And so understand the context, the skill of the person, and in a natural way what's mean. But, I think it's very easy to understand. Natural way means it's like I talk with another person. It's like the visualization that comes in front of me is obviously the most appropriate for the data that I'm analyzed, and things like that. So what do we do until now about understand the person? I think this was my typical way to start a project in data visualization. I don't know, experts in database in the room do the same, but you know, every time you need to understand the context. So you want to know how much will be motivated the user in front of you, so he will spend time to learn the visualization, or to be super simple, intuitive, ready to go. Is a domain expert or not, so he really understands the data that he is looking, a familiarity with statistics, what is a cognitive style, and the personality matter too. So, and in the design field, what you do is, when you build this web application, is a traditional persona, no? This segmentation of the customer, the user will come from you. This is the hero. They represent, the typical young guy, the typical businessman. And top to this persona, you are building the vision about what could be the user experience, the data visualization that they will be able to use. But in what way we can discover this persona automatically? So this slide is more sophisticated than that, it's more complex. But this is like a review, a short review of all the starting complexity points. Essentially, we need to know who is, and what believe in the feeling that I have about what we are close to present, the type of data that we are close to present, the think skill, what opinion, knowledge that you have about. And after, there is a context and option that play a role. So we don't just accept something because we offer a presentation of one single data. The world is complex. People are looking different type of input, different type of project, a paper. And at the end, of course, the main point is push this person step by step to go to explore, search, investigate the data, make the choice. At some point, have the final action. There could be make a decision, accept this paper, buy something, whatever it is as a goal of data visualization of user experience. So if we are able to comprehend all this stuff, we're able to create this type of dialogue that represent essentially something that you're feeling that is not just about voice, it's not just about text, it's about the body language in front to the screen. So if I talk about a computer, say, what happened there if there is a visualization? No? So I need to know all this body gesture. And I need to have a natural language understanding. So the code in real time, what I say. And all this stuff will go to my machine, the logic of my tool. There will be some task that the system will do to filter my data, to give me back something that really matters for me. At that point, the machine would have to do? I have to create a talk with me. So I have to convert the text in a natural language. And at the end, there is a code, and I work especially in this field, a code that will generate experience where there is voice. Maybe there is a robot that intermediates with me and the logic part of the system, and some database is very customized what I'm looking for. So why is it important? This is, I think, a very interesting experiment that we saw in IBM, and that I think is very diffuse, and now probably now you're confused. When you open a chat, you never know if there's really a person in front of you or not, or there is a machine. And we are able to not just generate content, but to evaluate all the type of technology, like when really a person is talking with another person. So essentially, we do this not just sentiment analysis, it's very now old school, we can say, but some more deep. Oh my God, sorry about. I forget to close this. Well, oh my God. Sorry, I think I have to, I don't know what way close the tool, honestly. Okay, I hope there will be a new message from Clio that she wrote me one time every 2 years, and she decided to contact me today. I never use Hangout, just with her. You can see by exploring the connection between what happened during the discussion, we can see the customer is satisfied because at the beginning there is a neutral behavior. After become anger again because they have a problem, he's not able to resolve, and after there is a neutral behavior, and after he enjoys the answer. So in our feedback loop with this type of dialogue we saw before, we need some emotional analysis to really understand the feedback the machine have with the person. So there are some consequences that we can see with some web application. Let's jump to this tool, and voila. So what happened is, okay, we can have this is a review from a restaurant, but can be any type of text. Is available online. You can, I will share the slide so you can test the tool after, so you don't need to write the link. But if I analyze this text, you can use any type of text you want, of course. What happened that I have an exploration of the behavior for different segments of the speech. Like at the beginning, you can see there is he's a really hungry, the guy, and a little bit sad. And then after a little bit, it starts to be a little bit disgusted. Oh my God, the conversation don't go very well in this speech. Step by step, you can see a type of data visualization that I have to explore the information that comes from this text analysis. And you can see the text change every time that I move. In this segment, we have a new text, so you can verify where the person go anger and so on. And what is it useful for? Essentially, is assisted and now is useful for a fast check about all the type of comment that come from the internet, but from this type of chat. But we're working to automatize this process. So essentially, to create the exploration of this and evaluate this type of conversation in automatic. And in what way this happen? Essentially, we need to analyze step by step the meaning of this word that we use. So I show you another demo that is free available online again. So let's see. Okay, where is my mouse? Voila. And I decided to have this interactive presentation. I hope you like the idea, no? To show you in real time what so you can have a different type of content, a main message, customer. This is an example, but you can copy and paste everything that you want inside. So the analysis helps you to understand what's going on in the text. So essentially, we can identify where is anger immediately, where emerged the disgust, the fear, the joy, and essentially is exactly what you see before, but step by step we represent in the text what's going on. In what part of the conversation there are different behavior. And look, that there is no sentiment analysis. We talk about be anger, be disgust, be fear, joy, sadness. So it's a little bit more sophisticated. So let's back to the presentation and let's see how much it's complicated to interpret all these information inside to the text. So it looks very easy, but in reality there is something like that. I show you one of the inside of one of the inside the tool. Oh, you have to put some text. Oh my God. Okay, from where? Okay, we can analyze some Wikipedia page. I don't know, just let's take some okay, let's do that. Obama. Usually a lot of good things come when you write Obama. And okay, this article, let's take these things. Just a short exploration of this text. Let's see the result. Okay, usually it's faster, always. Yeah. I'll show you different pieces of Watson technology, and apparently never do a demo with the SAI. Okay. Well, it need a little bit more time to analyze the text, so let's jump to the presentation. I will show you later. I take a video from you, Katie. I think this will be interesting. As I first, let's go to the video. Or let's take the link. You can do this with any type of video. And let's back to. So this is audio analysis, but it's not just audio analysis. It's identification of topics in a video. And this is something that we will explore a bit more in the next example. Okay, the video starts, and you will see in automatic, in real time, the system will start to analyze all the word. I hope you're happy to see you again in this video. So everybody jump. And what happened? Identify entity in real time. And we have a different level of confidence that these entities are appropriate or linked with some entity we discover in Wikipedia or in other But something more exciting happened during this entity exploration. We matched the entity that she talked about with all the entity that we find in other talk in TED. So in real time, there is a suggestion of what other TED is related with this speech. And more she's talking, more these suggestions are stable. You saw in the beginning, the suggestion was jumping from one field to another. Now, apparently, they are really sure that we talk about the future of cancer and HIV research. Now another topic emerge that the system consider more important. Of course, yes is not a band, but the system consider yes a band. So you can see how much is complicated, really identifying the right way entity. So in this case, we use a technology that really focus to very generic content. So it recognizes content entity in the field of pop music very easily, but no. In function to the type of information, the context, you can implement a different type of entity extraction that will really match with the field. So if you know that we don't talk about pop band, yes will never be an entity for the computer. But it's something very hard to teach. Anyway, these are real time. You cannot really listen to the voice, but I think you have to trust me that exactly this is the text. Can you confirm this was the content of your speech? Yeah. Yeah. Yeah.
Everybody has to just learn how to dissect it.
Yeah. Anyway, let's back to the presentation, and of course, this I think is very famous. There are so many API like that, but I think I'm always excited to present the quality of the work that our team did for the text-speech, because at some point you have to talk, the machine have to talk with you, and we need a type of voice that really matches with the user. So there are different type of accent, different type of slang. So you can talk in Italian, in French, in German, and the voice can be a female, a male. Now, of course, this really matters because we'll change the type of interaction. The conversation will be completely different. So let's try, I don't know, with this voice. And, oh, you cannot really hear. There is a jacket that I can, maybe for the audio, there is a way to increase the volume. Otherwise, I can just put up, I don't know. No, there is no connection audio. It doesn't matter. If we're in silence, we can really. My mouse is.
I have been assigned to handle your status request. I am sorry to inform you that the items you requested are back-ordered. We apologize for the inconvenience. We don't know when those items will become available. Maybe next week, but we are not sure at this time. Because we want you to be a happy customer, management has decided to give you a 50% discount.
You see the voice happy, when you say happy, is exciting. Because the system gives the option to the front-end developer to introduce excitement, sadness in different parts of the speech. So, and this is really something that will introduce a real conversation with a computer, because it can be sad, it can be scared, it can be, well, you can, if you go to this website, I will show you the link, you can explore for free this API and play with this different voice tonality. It's very exciting for people that never did before, because other free API just give you a voice translation, but in this case, we give you emotional voice translation. That is a little bit different, a little bit an improvement, but an important improvement. And so essentially, my work is in this chaotic situation to managing text, sound, image, video, and all these analysis that come from the colleague in the machine learning field. And after that, I have a semantic contest. I know where I talk, who is my target. The goal is to build visualization that change in real time in function of this parameter. And essentially, this comes from a very interesting publication. I think I transform a little bit this concept, and essentially I can activate a different level of engagement. I think, especially for some of the projects that you're building in the university, like the forecasting, this type of a link between gestural recognition and the dialogue that you can create with visualization really matter. So essentially, what we really do until now, many of you, is just looking at the data in front of your screen. Slowly, we introduce Cinetic, another device, to see some primordial body gestural, so we can start to create some interaction and say, zoom there, highlight this. And this is something that happened. The evolution is, during your activity, the system understands what you want to do and start to highlight some trend, some property for you. And start this dialogue. It's like, no, I don't think this is the right trend, and things like that. And at the end, together, you can come to a hypothesis, so a direction, some clear pattern that will happen in the future for all the algorithms that you decide to use to managing this information. And of course, the final goal is, again, take the decision and go to the next step of your work activity. Looks so innovative, but like what happened very frequently is artist people start to, in art, in 2012, was this beautiful project, Endless War. You can find online, I think it's a very interesting project, and where essentially there is the idea is very simple. There are a collection of data from WikiLeaks. They talk about the war in Afghanistan. And the idea is to give to the user the perception that from this huge amount of information was like 800 megabytes of just text, very clean text. So it's a lot of data that really few people can read. The artist was thinking to create this sound effect, this animation of something that emerged from the data. Now, my computer is not broken. It's really this noisy sound in this room. And I think we can avoid that, I think. And his idea is to see in real time, of course, is give the perception to the audience that is this real-time processing of the data to highlight some specific piece of information, where some important entity emerge. People are died there. When some crucial information emerges from this text, and the computer gives to you. And I like to create this link of what a business try to build and what artists try to deliver in like an experience, because in this case, there is this real a strong connection with the feeling that a machine can split a very sophisticated story in little piece of drama, or dramatic, little insight. In the same way, politicians can be so rational to decide in a very pragmatic way to make the war and make this happen. So essentially, there is a spiritual component, a poetic component that the artists try to put on the table too. There is not just technology that are emerging now. I think you have to think at this level of interconnection between the meaning of the text and what you are doing in terms of user experience, in terms of art, in terms of installation, like a big shift. Now we can use we can use the word cognitive technology, we can use sophisticated machine learning system to text analysis, whatever you want to use. But now we can create this dialogue. And the machine can be part of the way that we think, not just technology, but art too. So at this point, you're curious to see, okay, you work in visualization, so what is a data visualization, and in what way is it bring value in using this machine learning technology? So, of course, I think everybody agree that you want something evocative when you build art, and it's very beautiful, these green things, I think. Oh, I wanted the patent to do that. I think is amazing. Is the black they become this matrix. So, and a few years ago, maybe the idea to just represent a huge amount of information was enough to say, wow, look, this is the universe. This is like the World Wide Web plot with the metaphor of galaxy. So there are these big apps that become these big supernova things. So there is a metaphor that you really know, that you match with other type of content to go inside. But come on, listen, after many years of database, is enough. We don't want to more this type of spaghetti bubble, no? I think it was very cool in 2006, in 2007. Now we want the content. Now we want to really beautiful things that become content. This is one extreme, like this is a demo from one of our tool in IBM, and they present the way to explore relatively big network and different, you can see again there is kind of a universe, but what is the difference? Now there are multiple components to really explore and go deep. There are different mathematical element to identify cluster, to select some part of the data set. So essentially translate this network visualization in some geographical map, like what now Microsoft is doing with SAND, this project. And essentially, we can build beautiful stuff. There's beautiful, this old cutting line, but at the same time, delivery, sophisticated, always more sophisticated interaction component to really go inside the meaning of the data. So today we will see together something about that more in deep. So we open some very interesting tool together, and I need to tell you that. I look in network everywhere, so I have a feeling the network are really everywhere. So this is just the project of the last year. So every time IBM proposed me a new project, I always put a network inside. So I don't know if it's positive or negative, but until now, everybody are able. I have a good feedback from the company. Network visualization are really everywhere, but this is another very famous paper of 2002, where essentially you plot. Kind of the very similar network, but with different speed, with different algorithms. And you can see that the same network can be what? What type of pattern emerge from this different network? It's clearly that it's not really just the network that really matter. I think we have few experts in this room, they're really not, but the type of algorithm that you put to identify the relation between will generate a different layout. And what is the best layout? Of course, there are some mathematical criteria to identify a good layout in a network visualization. And of course, you want to avoid edge crossing, obviously. Many tools are able to do that, but are able to do that for a big network, are able to do that for a big network in real time. No, this is still a big challenge. And you want to avoid edge crossing angle, and you want to, of course, you want to avoid overlap as much as you can't. So there are some mathematical component that criteria that you can follow to really plot fast a beautiful network. But there is a big gap between what we know in network science and what really people do. What really people do is use D3 to plot a network. This is a big drama because D3 don't really support a big network plot, and the layout is very ugly. So I show you the big difference between, this is a visualization that we made, and in less than 1 second, you have this layout. And this is a visualization that comes from D3 after 20 seconds, because you need, the system find an equilibrium. So of course, you cannot really interact with network if you have to wait 20 seconds to find the final equilibrium stage. You want something faster, and especially, it's not so useful plot a network in this way. Okay, it's optimized maybe to stay in small screen, it's a strong bar, but look how much is easy to identify different direction of the network here. So really, the layout matter and the velocity matter. So what we did it in the laboratory, and will be released very soon from the company, is increase the number of metrics to have this tool. Let's see together. Let's open the application. I'm sorry for the beginning, I don't really like it, but the sense it's too big. Where is my mouse? I lose my mouse. Do you see my mouse? I don't really know. Ah, okay. Let's reconnect. Ah, okay, yeah, I'm connected. Okay. Something doesn't run. Okay, sorry for waiting. Essentially, I have this network, and no. Oh my God, it's so big. Okay. The resolution is not really what I was thinking, but okay, you can of course manipulate everything inside, the size of a link and whatever. But what I want to show you before they go in panic with this, because what is it? Right, I can no. Okay, you can change, for example, the network layout. And this happened in, for 1000 stage, this happened in kind of real time, a few seconds, or for some type of layout, this happened in really a few seconds, few milliseconds. And what is interesting is that you can not just look in the network, but evaluate the level of readability. Wow, I cannot read the icon. Okay. Okay, there are different parameters. Where is the parameter I'm looking for? Okay, node size, overlap, for example, is more easy one. Sorry, because I'm looking there and moving here. So, for example, node size, what's mean? That in real time, the system can identify, this is work, okay. Sorry for the very stupid example, but it can do the same for so many other parameters. Essentially, there is a readability matrix that can, in real time, identify what's wrong in the visualization. The angle of the edge is the right one. If there is overlap, where is overlap. Now I increase the size of the node just to make clear to everybody that when the node increases, immediately the color will tell you, okay, this is green, is good, this is red, is bad, there is a strong overlap there. And this is the most stupid example, can be done for many other parameters, like edge crossing and angle of the coherence distance between the node in the network. More than 8 parameters that help us to identify how much is readable the network. Why this is important? An idea to give you a little insight about this type of technology, because let's back to the presentation. Essentially, this is like the matrix where we compare different networks, and we have clearly in this more ugly representation, in this in this matrix, a view of what is the best layout to use. It's important because to build a visualization in automatic, you need to give to a computer the criteria to select a visualization compared to another one. And this is incredible hard work. Now we just compare network layout, but it means to compare different type of visual metaphor. That's what we are trying to do now. And the criteria of readability. So, you know, for the machine to do something, had to be a very logic sequence of rules. Had to be a criteria to select something compared to another one. So in some cases, easy. In a network visualization, there are some mathematical criteria to identify when it's more readable, when it's less readable. It's more hard when you compare different visual metaphor. Why is more readable, and why is readable for this type of data set and not with this other type of data set? But it's possible to do. So we try to create this big representation for the machine with the mathematical criteria to give the machine a way to select in automatic the best visual metaphor, and when you select something, to plot in a most beautiful way, like the right distance between bar, the right distance between a label and a pie chart, if we'll choose a pie chart, if sometimes can happen. And this level of compare, the same visualization with this level of readability, is what we call readability metrics. Now we apply in the network visualization and in few other visualization. And this is like a starting point to build this automatic process. Of course, after there are so many other components, like you want to plot a huge amount of information, so we are building this million of elements in plotting WebGL, but I think everybody do that. And we try to increase the layout in function to many parameters, like when the layout has to be plotted in a iPad, so they want a kind of a compression. This is a mix between a network and a bubble chart, but in reality, the location of this bubble have a meaning in function to the level of connection between the other bubble. And when you zoom inside, you have a perception when you navigate in this type of picture that well, the resolution is not really super good, but you can read inside to every single component, and they have the impression to have a big picture in front of you. So this is another element that the machine can do faster and better compared to other. Sometimes the criteria is a little bit more simple, like in this example. Let's see. Okay, we can avoid this example. I think it's very, it's another demonstration of visualization of network, but we can avoid that. I think because we have other 20 minutes, so let's jump to the next topic. Oh, where is my mouse? Every time they enter in, where is my mouse? I don't really know. Okay. So let's back to the presentation. Another part, of course, there is a component, there is a created technology to build automatic visualization, and there is another component that makes visualization available on the web. Because in my case, is the main criteria to work, and probably is a way to really deliver content for this type of cognitive system. So what we are doing is build a technology that can be fast enough and independently for the amount of information. So was a guy that was working with us last year, and this is one of the results that come from data from Sensible City Lab that show exactly the quality of WebGL application in function to the frame per second. They have to be always, I think you know very well how much it's complicated, have a very big amount of information in front of you in a full canvas and maintain a frame rate of 48, 47. And this is the boring part probably in working in data visualization, but without having this skill, you cannot really, not just impress, but really deliver a visualization that is useful, that you can really navigate and interact with. So I think we can jump to I don't know if you're interested into looking what is possible to do with data that come from city, but I think when there is a general audience, usually everybody are excited about that. This is one day in Dublin, in a smart city Dublin, and we collect all this data about where the cars are and where pedestrians are. So there are different sensors in the city, and the bus movement. And the idea is very simple. You have a big picture, the Twitter connection, have a big picture that shows you what's going on in the city. So there are different layers you can turn on or off. And after there is a 2D layer that you cannot read very well, but essentially a 2D layer where you can drag and put there the information. So we know that when it's a 2D, the information is very easy to read and to compare. But we know that when we have, you are able to create this 3D world image with Oculus glass, no? Entering this dimension where all this data emerge, people can really find this type of experience like a video game and be more happy maybe to just monitoring the traffic condition by looking at the intensity of a red and the green path that really change. So think if you are to evaluate the traffic transportation in Dublin, you can select to visualize in the map 1 month of traffic or just real time or 1 day. This means that you can highlight very quickly and help the brain to find so quickly where is a part of the city that have a problem that is always the same, that every Saturday maybe happen. When there is some path that really emerge in this, because this area become red every Saturday, maybe something happened there that we can resolve. Because, of course, you can just plot the data or do something a little bit more sophisticated, help the machine to find the pattern. So you can introduce in this data some algorithm that highlight some property and cancel other property of the movement. So you can see the same plot, they look, okay, in this screen, everything looks crazy, but well, the same plot, but looking completely different, and I like different property of the data. Essentially, this is an aspect that I think is a very common way to looking about data visualization for big data. That means we don't plot more data directly to your screen because always are too big. We always use a model to filter our data set. And what's really happening in the interactive tool is select the filter channel, the property to aggregate, to put together, to disambiguate, whatever you want to do with your data in front of the user. And the user has to play with this model. So the interaction is with the model. That will be the only way, the only lens that you have to really catch a huge amount of information. So this is a static method merge. And let's see together this example. And let's see if we are able to. Okay. News Explorer. Let's see what resolution. Oh, looks very good. This is a News Explorer. Is one of the tools that I'm happy to present to you. How many of you know the News Explorer? How many of you? Oh, one. Congratulations. No more? Okay, you. First, I want to tell you that if you're using this tool, you are able to find patterns that other people are not able to use, not because it's better, but because it's different. It's not just Google News. It's a tool to explore the flow of news in real time and show you what type of entity emerge. In function to different fields, like business or education, you can see what is a merge. Of course, the size mean this topic is very important now, and the color mean people talk a lot about petroleum, but in a negative way, because it's more red. So the sentiment analysis is inside. Some of the main research is going on now, and after you can have a big overview about the article that are now the system is taking from different resources, different journal, different blog. You can see that it's kind of the same philosophy. Essentially, let's see the explication from the size of the title represents how much is prominent at the moment, and the color if positive or negative. So you can write everything you want in the search area. So I'm looking to explore some specific topics, and now we will do it. And I don't know, let's try Indiana. And there are news about Indiana. I don't know if it really matters for you, because I'm not from this area, so I don't know if they are very relevant news. But you can click one of these components and enter in an exploration side of the news. Essentially, when you explore the news, you do something very cool that is like an aggregation of the technology we are looking until now. So we build in automatic a network, and this network represents the news about Indiana, and are all these green elements. You can see, if I put the mouse on top, I can see the title. If I open this element, essentially the system will highlight for you in these three entities, company, organization, and people. And you can see there are some entities that become very prominent, one close to another, and this maybe means something. Okay, Donald Trump always emerges now in any type of news that you write. On this, maybe there is something more interesting to write. I don't know if you have some. But let's try a classic one like Obama game. I don't know. Let's see what Barack Obama is doing now. And now we will see what's the meaning of the other area. Of course, there is a temporal vision when the news emerge, and there is an overview about the main topics that emerge from the last 100 article. These are free available too, so the limitation is the last 100 article. Doesn't matter how much news are about these topics. And there is a word cloud navigation system where you can see entities that emerge in the news. So without entering every single news, you can look from the network visualization that Angela Merkel is very close to Barack Obama. If you want to know why, you just click maybe Angela Merkel, or you can click this word cloud, and the paper they talk about both will emerge and are highlighted for you. But there is this other person that is really important, Donald Cameron. And maybe you want to see one of these articles, so you can click. This is a preview. There are all the entities that the system finds inside. You can just read the full article and go deeply and discover why Barack Obama, Merkel, and are all together in the same network. And why is a very powerful way to explore information? Because you can find a connection between entities that are completely invisible with any other tool. For example, if we go to Donald Trump, Vladimir Putin, it's very popular comparison. This is another capability of the tool. You can compare entities. This means that we're plotting the top 100 article about Vladimir Putin and the top 100 article about Donald Trump, and we find the network of interconnection between these two networks. This means that all these elements on the right regarding topics are related to both. These people are related to both. The company are related to both. And of course, you can explore and understand why. Organization. And Russia, click Russia, you can see all the articles that talk about Russia. And on the left, Russian and Donald Trump. On the right, Russian and Putin. What is very nice, now it's a bit chaotic. If we cancel the entity correlation, we just highlight the article. There is something that nobody is able to do today, is to visualize article that contain both entity is very common. No, you write in Google both name, you will see the article that contain both entity. But what about article that contain this entity and another entity is related to Vladimir Putin? So 1 degree of separation. What about 2? We try 2, but everything is connected. But just 1 degree can help you to find very suspicious stuff. Like, of course, now we are working with the flow of news. Benjamin, I don't know why Benjamin is you can click, of course, we take from Wikipedia some information about entities that are famous. You can find, if you apply this technology with a CIA document, maybe something very interesting will emerge. But still with this flow of real-time news, maybe some journalists find interconnection that otherwise are invisible to find. So anyway, the tool is free, is online. It's incredibly expensive, so it's free. But believe me, there are many machines that are running to give you this real-time service. So take for free and in happiness. Maybe in this way, you're able to tweet very original news because none of your friends are using the same technology to find news. And in a sense, frequently people tweet stuff from Google. I don't know. Anyway, could be a useful way to really explore the flow of news. And many news, we use more than 175 sources, and we're monitoring this source every second. So it's really in real time. So if you want more technical specification and information, you can find all the type of source and how much frequently we refresh the system and things like that. If we back to the presentation for the last few minutes, I'm happy to present you another project that I think is very interesting. I think you see something before when I was exploring with you the voice from your video. And we can see what's really inside this type of technology. So I was part of the team that made and create from zero. So with Dario Gil, I'm one of the inventors of this application. Is a Ted Watson. Ted is a name. Is free, available online, and I will share with you the. So you can read very clearly all the entity, the topics we discover in different fragments of this video. So essentially, the technology works in this way: identify everything that emerges in the video by transform the audio in text, and try to extrapolate the more meaningful segment. So amount of information that is enough to complete the topics. So essentially, we use different technology to identify when this fragment is the right one. Of course, it is changed every time and looking for different type of topics. It can be from some topics. The fragment can be from second 3 to 20. For other topics, it can be from second 3 to 28. So it's something dynamic. But the fragment that I give you back will become more clearly by looking at the application. Why I talking about this fragment? Okay, Ted. No, this 1 second. I open. I put that. Okay, that. In what way it works? So you have to log in, but you can it's for free. So you have to just give you some information, and with all the privacy criteria that you want. Essentially, we mix a different technology. Like you can look in the content related to your Twitter account. So you can put your Twitter. We will explore your Twitter, understand what you're really looking for, what is your passion, and we will suggest the topics inside to the video that really match your interest. If you want to give me your Twitter, otherwise I just click one of these Twitter, like I think everybody are curious to see this. In this moment, the system is exploring all the Twitter activity of the candidate, of Bernie, and there is you can see the personality inside is changing because it's reading all the content. And then this is the final profile. And there is some visualization, but it's not really super meaningful at the moment. But something we know the profile of this person, we know what you care about, and we want to know if there is some content that really matches with this person inside to the TED collection. So the system is still analyzed. Let's see when it will be ready. 1 second. Oh, yeah. Oh, yeah. If you have a question in time when it's analyzing. Yeah, usually it's much faster. Anyway. I show you, it's analyzing. I show you another property because we don't have too much time. You can ask any question you want. And because the tool is free, you can play at home. So you can, so just let's see something that is available now. I don't know. What is the secret of happiness? I think it's something that everybody wants to know. And after you ask this question, will be a collection will made for you. Oh no, this is a Bernie, I think.
Hi, my name is.
Sorry, 1 second. It's coming with the collection of segment of video. We take in this free edition just the top 5. Yeah, this is calculating. Okay, it's here.
People began to
Okay, the audio is not so good, but...
My home mailbox, not just with postmarks from Washington, D.C., but from Texas, California, Vancouver, New Zealand, Iraq. Soon my crazy idea didn't seem so crazy. PostSecret.com is the most visited advertisement-free blog in the world.
And, there is this sequence of rewrite of different segments that come from TED and
So
TEDx.
given that that's true, how good are we at increasing our happiness? Well, we certainly try. If you look on the Amazon site, there are over 2,000 titles with advice on the 7 habits, the 9 choices, the 10 secrets, the 14,000 thoughts that are supposed to bring happiness. Now, another way we try to increase our happiness is we medicate ourselves. And so there's over 120 million prescriptions.
Yeah, unfortunately, medication. And why I think this is very useful?
It's not going to be particularly profitable because they don't want stuff enough. I want to suggest to you that synthetic happiness is every bit as real and enduring as the kind of happiness you stumble upon when you get exactly what you were aiming for.
Okay, the other video, but what I like to you is that during the video we identify different topics, the main topics that emerge in the rest of the speech. So you can easily click and jump when you want to another video, another collection of video that talk about psychology. So why I think this is very innovative, because it's a way to match your personality, the personality inside, the way that we explore your interest, the text analysis, the way that we can transfer, identify entity and topics in a way to explore video. And, okay. Now is going to the part of psychology in this speech. Anyway, and there is new collection that's moving. Let's stop this video. I think you will really enjoy explore TED content in this way, because it's a very original, and we build this project in collaboration with TED. So very soon, inside to the TED Engine website, the system will work with this technology. But it's not ready yet inside to the TED website, so you can play directly with this application from the link that we'll share with you. Let's go to the final part of the speech, and let's go a little bit quickly, because I think you will be happy to see this visualization. You should never see before.
Renaissance artist Leonardo da Vinci was born near Florence. Known throughout Europe, he was employed by the King of France late in his life. He died in Amboise in the Loire. Da Vinci is one of over 100,000 notable people whose birthplaces and deathbeds have been mapped in this animation. It's the work of a team led by Maximilian Schick, based at the University of Texas. The team wanted to chart hundreds of years of culture. Births are blue, deaths are red. Let's start in the Far East. This is 17th century Japan, just opening up to the west. Many of these names are Christian missionaries to the country, some persecuted here for their faith.
Okay, I don't want to see the video with you because it's online, so you can just watch. There's no reason to watch together here. But I have a big news. Present to you for the first time the interactive version of this application, because I think there is some voice that say, oh, exist, don't exist, exist. It's online, and now I show to you, and I think it's very beautiful, but you can tell me what you're thinking about. Let's close some of this application. Let's refresh this page. Et voila. I don't know if the resolution is good. Here is very good, I think. Yeah, it's very good. And sorry for the people that have to look at the green. No, there are no more green stuff there. So what happened? Essentially, you can select some interesting area, for example, Italy, from 35 to 18. And you can start to see, I don't know, important people that move. You can see, I'm interacting now, you can see in what way Rome become more and more important. You can accelerate, you can move in the time, you can do whatever you want. You can essentially go full screen in case of museum activity, or side view. I think it's very fascinating, the side view. Now it's very small network, but if we accelerate, if we go to 8 per, very fast, you can see the network room become bigger and bigger, and more influent all around the world. And you can see the people that move in different areas of the planet, but let's back to the other view. I think it's more fascinating. We can see the people or not, the people label or not, city label or not. And something very nice is, okay, we can easily resetting and go. For example, I'm curious to see what happened in US. I think looking US is very interesting now. So let's accelerate a little bit to see the first people that come in US. They are coming. We are close. Okay. Here we are, here we are. Let's go to one. Eccoli qua. And slowly, new cities start to emerge, so you will see new label of city appear on the screen. And so let's zoom a little bit. Yeah, there is, of course, the first one is Boston. And Boston is super connected with Europe, but look what happened now. New York is very connected with Europe, but slowly, this city will become like the generator of new talent, the new people with skill for all the USA. And George Washington, who is this guy? I don't know, he's left. But you can stop. You can now I show you other property of the screen. You can see finally this thing is interactive, no? And there are so many problems in creating interaction like that, in the sense that you need to really calibrate the amount of information that people can manage to maintain always. The frame rate in this case is always around 58, so it's very high. I don't know, you can touch this line and see who is this guy. It's James Bogart. I don't know who he is, but you can zoom inside. And now there is this high line that emerged. You can see the node change size in function to the level of zoom. This is a nice function. And you can stop when you want to start to explore more deeply this information. And there is a version I was creating where you can click the name and know information from Wikipedia, but it was too complicated in terms of the software was not so performing after, so I decided to take out. And this thing is made with a good friend of mine. And so essentially, there is Maximilian Smith that is a part of the project, and another good friend of mine that we work together to optimize the performance. So it's not just easy. I won't just say that before to close, because I have other 2-3 videos, but I think we can close and start the conversation. Because honestly, I was thinking it was 2-hour speech, but I realized just a few minutes before to start, it was just 1 hour. So sorry to jump so quickly from one topic to another. The idea was to be together for 2 hours. But let's close with this visualization just to say that I think building a video that explains the content from a new data set that you find where is a great story is the best way to really share to the big audience this story. Because people don't really want to spend too much time interacting sometimes. But when you move this story from the web to the museum, for example, to the exposition, everybody go there and they feel they want to explore. So the context is completely different. It's not just a 5 minutes during my coffee time on the web. It's a place where I spend 1 hour in the car to go to the museum, where I want to really learn something. At that point, I totally agree with many of you, it's a time to transform the experience from the video to an interactive tool. This is not easy. It's much more complicated because, of course, now you want a web application, so to run everywhere. Had to be optimized for big screen, for touch screen, whatever you want. Had to be fast, had to be meaningful, had to be with a lot of user tests to understand. There is a lot of user tests. Of course, my girlfriend a friend of mine. So, yeah. So but there is some enemy too. So there's some people that hate me that give me some feedback. Not too many, unfortunately. But now I think is a good time to really transform some of the effort that you put all the day in your scientific process to build a new advanced paper, to really innovate in journal like Science and Nature, the boundaries of knowledge, to take a time, money, effort to transport some of this content with this technology to the broader audience. Why I think this is very important, because the science is the number of universities around the world now is unbelievable. Compared the number of PhD that exists now on the planet, I've never seen before, and it's a time to really share how much we can of what we know with a tool that engage everybody, not just people that really focus in some content. They're really with a passion to explore, to take a little bit, a glimpse, to observe a little bit, maybe be curious, maybe this would be a starting point to explore with the tool and maybe make a career in top to this just visual expression of the knowledge. But the knowledge now has to be something for everybody, and by the same time be connected to the data. So be really able to show to everybody what the scientist is able to see. So without any intermediate, without no more, of course, I hope we'll never stop a scientific journalist to deliver it, to simplify content. But I think we can, in our team, build a unit, small, sometimes it's just 1, 2, 3 people, to delivery of the same data set that we use to build our paper in a more easy way. And we have to trust that the number of people with a great skill in the world are increasing in an impressive way. So the audience from a small, invisible university is becoming a big, invisible university. This university of people that are our same passion, in our same field. So these universities are becoming bigger and bigger, so we need to be ready and offer application like that. I have many other content for another hour, but I think it's a good time to stop, and thank you so much. Thank you so much.
Now or during the reception. Thank you so very much, Mauro, for preparing 2 hours. Sorry for miscommunication. And maybe after we all had some chance to actually get something to eat, maybe we can see some more of the visualizations. Are there any urgent questions right now? 1, 2 quick ones. There's one quick one over here.
Yeah, it's my own hubris. Any question I want to ask is urgent. This is really awesome work. And I'm very curious on the conversations that you have as you're developing it about the ethics of data representation, particularly in that data points that are not observed are data in so much as the data that is observed. When you have this map of the United States, you can see who is represented from the birth and death. But I imagine if you scrolled out to Latin America, you wouldn't see nearly as many points, but arguably there's a major amount of culture within Latin America. So when your team is working and representing information, can you talk about, I guess, the framework that you go through from the ethical side of what information is going to be represented, how is it going to be represented, and then how are we going to give people the tools to explore in a way that doesn't distort the bias of the creators?
So the feedback from this video was like 1,000 of comments, and some friend of mine called me and say, my uncle is not there. What? He's a famous artist. Why is he not there? Sorry, just send me the data, we'll integrate. I don't know. I was not really able to do that because, of course, there is a scientific approach. There is a criteria to choose a data set. In this case, it's a free-based data set. So it's made by Google. The criteria are really with strong bias about American and European culture. So in the publication, we clarify that this is a strong bias. So people that read the paper know very well that we cannot represent Africa for what really Africa is able to express and deliver in terms of cultural change, because nobody take a time to transfer this data on the web. So it's not available. And in China, probably these data are available, but in Chinese and not yet in English. And unfortunately, it's very hard to speak so many languages. So I speak personally 3 languages, but Chinese is very hard. So very few people can really go into. Now we have the support of this artificial intelligence system that translates for us many content so well. So things will change. But until 2014, the time of publication of this work, the situation was very, the state of art of the quality of the data about important people that influence our culture. The best way to work in this field was just use Freebase. And this question is more for Maximilian than for me, because I don't really, I really like to make clear every time what is the boundaries of knowledge that I'm able to really to be confident with. And because it's frequently, I just published a work in Nature 2 months ago. I started to receive calls from journalists asking me about quantum physics. Saying, well, it's not quantum physics at all, it's a paper. But no, when I was published this work with Laszlo about controllability network, people was asking me about controllability network. And I don't know anything about controllability network. I know enough to build the visual model. So this question is a classic misleading. So you see the person that built the way to managing the data, and the question, of course, is about the story. But I'm very happy to receive all the time this question, because I really feel that database is successful when it disappears. When we just think about the story. You don't think about the technique. And I really love that nobody talk about technique about database, because the database have to disappear if it's a good project, and because you have to just remember the story. But beside of this quality of the project, then people think that I'm a theoretical physics or an expert in. I'm not. So yeah.
Mauro Martino works very, very closely with quite a number of different types of researchers. And that's really a unique skill to have, being able to work with Maximilian Schick on the story, to work with Laszlo to work with biologists and others on kind of different projects. Ultimately, I think you're right that by giving it a form and a shape, you do impact how people perceive some data, but this is why you have disclaimers, this is why you describe what kind of data mappings have been done from the data properties to the visual encodings, be it form, size, shape encodings. And ultimately, some of you might like to ask Mauro, hey, can I get my data in there? And I think that is a question we can answer, and then we can talk about data formats, etc. So, in the interest of time, let's thank Mauro one more time and then go.